Alright, moving on, in this video we are going to create the style class for our project demonstration. We're going to create a class that is going to contain all of the visual and texture reference information that will be used throughout our project. This is going to be used for things like textures, fonts, and colors. The reason we're going to be assembling these all into a single class is to give one single point of reference to grab all visual information. This is as opposed to looking at individual instance fields actor by actor. It alleviates some of the code necessary to create things like actors and later our navigation actors. So, to get started, what we're going to do is we're going to create a class called style. So this is going to be a static class that will contain all of the visual properties we would like for various things that will exist inside of our project. So we're going to start here in the behavior demo project, and we're going to add a new class. This class, of course, is going to be called style. And inside of the style class, the very first thing we will do is mark the class as static, just to make it easier to remember to drop all of the fields in place also as static. Now we're going to need some using statements for some of the basic types as well as graphics and content. And once again, just to save a little bit of time, we know that we have already created just such using statements inside of things like the scene class. So I'm going to jump over to scene where all of these lines are conveniently still highlighted. I'll copy all three of them and drop them into style. So again, looking at framework, graphics, and content. Now we can move into the style class itself. Now this class is going to need to contain a series of fields, colors, fonts, and so on. So I'm simply going to go through these one by one as we create them, and we'll explain what they're going to be used for. The very first field we're going to put in place is a color. So we will make a public static field of type color, and this color is going to be our node color. We'll set this to be a value indicated by a new color, and we will specify the individual red, green, and blue components. The node color is going to be a light gray in color, so I'm going to specify values of 200, 200, and 200. Now the node color is going to be used to indicate the actual points of navigation inside of our scene. We're going to take the actual network creation objects and term those as nodes. Nodes are going to be used for path-based navigation. So node color is simply the color to use when drawing the node indicators. Moving on from here, as we go through and create these colors, I'm going to begin copying the last one and pasting it in just to save some time on typing out public static color. So we'll progress by duplicating node color and changing the name to selection color. And selection color is going to gain the values 144 in red, 238 in green, and 144 in blue. Now, the selection color is going to be used for the editor portion of this project. We're going to put together a node editor, and this will let us assemble navigation networks. And in order to work with objects on the screen, we're going to have a color that indicates whether or not objects are selected. Alright, moving on from here, I'm going to duplicate one of our color fields, and we can move on to the line color. So we will make a color named line color, and we will set up values of a dark gray color. So we're going to set up 80, 80, and 80 in red, green, and blue. Now, since in our demonstration, paths are going to be represented as lines connecting any given nodes, so we're actually going to draw those visually, and we're going to use this color in line color whenever we draw lines to the screen. Alright, moving on from here, we have closed color. Let me duplicate this in place, and we'll call this color closed color. It will have red, green, and blue values of 255, 200, and 160. Now in these cases, there are some terms that we're going to get into much more in depth as we begin looking at our pathfinding demonstrations. So simply at a high level, you can look at this as a certain, you could say a certain property that's going to be attributed to a node. And when we get into that, that property is going to be important to us, and we need to be able to tell visually whether or not it's set. So this is simply to indicate the closed state of a node. So moving on from here, we have the color path color. This color will contain the values of 180, 180, and 255. So we'll have a light blue color. Path color is going to be used after we have calculated a path and need to highlight what that path actually is, or creating a nice bright color so we can see the path that ends up resulting from all of our calculations. Alright, moving on from here, we have a few color values that are going to be used to draw our text. So I'm going to call the first of these bright text, and we'll set this to a value of pure white. So I'll set all of the color components to 255. And in addition to bright text, we are also going to have dark text. And dark text is going to be set to an RGB value of 150. So 150 in gray. Again, we have one number that's going to be more prominently used in calculations, and some additional information which is still nice to have, but we want the bright text to stand out. So we'll create some very simple color fields. Alright, with these fields created, we're now ready to move on to our actual fonts. So we'll make a public static field, this time of type sprite font, and we will call this font large. Again, this field is going to be used to reference the font large sprite font. Now, in addition to font large, we of course also have font small. So we will drop in a second font field. Alright, now we're ready to move on to all of our textures. Now we're going to be needing the arrow texture that we had earlier, but in addition to this, we're also going to need a fill texture, which will be a generic 1 pixel white texture that we can use to fill arbitrary rectangles. We'll also need a texture to draw our place, you could say our path node actors, and we'll also need some textures used in additional debug information. So let's get started with fill texture. This will be a public static texture 2D field, which we will call fill texture. After this, we need arrow texture, and now once again, since most of these definitions are the same, I'm going to begin copying and pasting definitions so we can simply change the name. Our second texture 2D is going to be the arrow texture. After this, we have the node texture. Now, after node texture, I'm going to drop in a new texture 2D that I'm going to call marker texture. Now, the marker texture is going to be used for additional debug information as we're looking at nodes. The actual texture that's going to be used with marker is going to be a simple circle. So think of a circular ring that will be used to, well, you could say encircle any actor of interest. So we're simply going to draw colored markers around any of the nodes that end up getting used in our pathfinding calculations. Now, one interesting thing about the way the marker texture is going to be used is it will not be drawn as an actor. Of course, with things like arrow texture, we don't need to worry about saving an origin to draw this texture, since actors are already centered around their own origin. With marker, we're not going to have any marker actors, but we would like to draw the marker texture centered around a center point origin, so we're actually going to store an origin here inside of the style class. To do that, we'll drop in a public static vector2 field called marker origin. Now, one last texture that we'll need when describing the inner workings of our pathfinding code is going to be a texture called tail texture. Let me drop these in place, and then we'll explain what they do. I'm actually going to grab both lines, marker texture and marker origin. since once again this will be a texture that needs to be drawn with the same origin center of an actor, but it is in and of itself not going to be an actor. Now for the names here, we're going to use tail texture and tail origin. Now the idea here is to present a simple directional indicator. Once we create a network of path nodes and calculate a path through them, it will be important to store parenting relationships between nodes. And we need some way of telling that node X is parented to node Y visually. So what we'll do is we'll draw a short line where tail texture is actually going to end up referencing this line 22 by 3 texture. So graphically, all it's going to be is a short line. But the idea is that we will rotate this line around the actor to point in the direction of its parent, and that will give the parent directional indicator. Alright, with that, we have all of the fields defined. We just need to add the code that is going to load up all of the appropriate content into those fields, because of course we need to load up our font and our texture assets. To do this, we're going to add a load content method to the style class. Just to make sure we keep everything nice and clean inside of the game, we'll offload all of the individual load operations into a single method. We'll define that method here in style as public static load. Actually, let's set the return type here to void, and then call the method load content. Now into load content, we'll take in both the graphics device and the content manager to make sure that both of these are available as we would need them. So beginning with the first, we have graphics device. We will call the parameter graphics device. And we need our content manager. So we will pass in a content manager parameter called content. So with those two parameters, that takes care of our method definition inside of load content, and we're ready to begin initializing our fields. We'll begin with the font fields. We'll take our font large field and set that to be equal to content.load. We're loading a font, so we will specify the type as a sprite font. Then the asset name, we can simply refer back to our content project and find font underscore large and font underscore small. In this case, we're using font large. And with that, that takes care of the call to content.load. Now for the small font, we can simply copy this line, duplicate it, and change the names. This is going to refer to the font small field, and we're going to load in the asset font underscore small. So looking at this, that takes care of our fonts. Now we're ready to move on to textures. We'll begin with the fill texture. Now again, the fill texture is going to be a 1 pixel by 1 pixel white texture. This is useful because we can modulate the color and resize it to the shape of an arbitrary rectangle. Now in this case, we don't have a 1 pixel by 1 pixel texture, so we're simply going to create one on the fly. So to do that, we'll take our fill texture and simply set it to be equal to a new instance of texture 2D. Now, of course, to create a new texture 2D, we need to know what our graphics device is. So we'll take the graphics device parameter that we're passing into load content, and we'll plug it into the texture 2D constructor. We also need to know the width and height of the new texture. We already know that we want a 1 pixel by 1 pixel texture, so we'll feed in 1 and 1 for our width and height parameters, and that will take care of the texture 2D constructor. Now, the problem with this one line is we will have created a new texture, but all of the color components, red, green, blue, and alpha, are currently set to 0, which means we have a black transparent texture. We need to set this to a white texture to be able to use it with our color modulation. So in order to do that, we will call upon the fill texture's setData method. And we'll be setting the data using the type of color. So we'll pass in color for the type. And for the data to be fed in, we need a color array. So we're going to assemble a color array in line here containing a single element of color.white. And that will, in the array, represent our single white pixel. So we'll put this together as a new color array, and then we'll specify the element in this array. So we'll start a curly brace and drop in color.white. Then we will drop in our closing curly brace. And with our array definition, we can now finish off the parenthesis for the color to set data, and finally terminate the set data statement. Alright, moving on, we now need to address our arrow texture. So again, we can load this from inside of our content project. So we can say arrow texture will be equal to content.load, specify the type as texture2D, and then specify the asset name, in this case, arrow. Alright, we also need to load in our node texture, and we'll use exactly the same procedure. So I will copy and paste to duplicate the arrow texture line and change the name to node texture. And then we'll change the name of the texture itself over here to circle 16, which might seem a little odd compared to arrow or node. Let me get this dropped in. The idea with all of our debug information is that I'm simply naming the textures to describe what they actually were. All circle 16 is a texture, 16 pixels in radius, or excuse me, I guess 16 pixels in width, all the way across. That is a white texture with a transparent background. So the idea is that we can modulate the color of the circle to any color we would like and have it draw appropriately. This goes along with our naming for all of the debug textures, where ring 24 is a 24 pixel wide ring texture. So basically we have a drawn ring, but the center is transparent. That way we can draw a ring around a circle, and that will make the basis of our debug information. Line 22 by 3 is just that. It is a line texture, 3 pixels in height, 22 pixels in width. And this is intended to be rotated to point in the direction of a parent node. So now moving along with our texture field loading, we need to load up our marker texture. So marker texture, and looking at this, I think I still want to stay lazy and copy our line, so I'll duplicate the node texture line and change the name to marker texture. So we'll have content.load. The marker is going to be the ring, so we will count the ring drawing as a marker. So this will be a texture of ring 24. Now, of course, the markers don't have actors, so we need to know the origin to use when drawing a marker, so we will also set marker origin here. Marker origin will be set to a new vector 2, and that vector 2 is going to be comprised of half the width and half the height of the marker texture. So our x component for our vector is going to be marker texture.width divided by 2, and our height, or our y component, is going to be marker texture dot height divided by 2. Alright, that takes care of the marker texture and leaves us with the tail texture. I'm going to duplicate both the marker texture and origin lines. We'll of course change their name to tail texture and tail origin. The tail texture is going to use the asset line 22 by 3. Now for the origin, we want this to be set up so that we can rotate the line around one of its ends. So what we're going to do is we're going to set an origin that lies on the left side of the line texture and is centered in height. And the idea is that we can take a line from one of its ends, rotate it around that end to point in any direction. So that means we'll take our vector 2, we'll set the x component to 0, and we'll set the y component to tail texture.height divided by 2. So it will rest on the center of the texture in height. Alright, with all of these fields in place, that should be all we need to take care of inside of style. We just need to make sure that the style initialization gets called from inside of game. So we'll very briefly jump over here into the game class, jumping down to load content. Now before we create the scene, we're going to issue our call to style.loadContent. Then we'll pass in the necessary parameters as the current graphics device and the current content manager. And actually that content manager field here is simply going to be content here inside of game 1. So with all this put together, we have our call in place. I'm going to briefly run and just make sure that all of this code does execute without throwing any exceptions. We're presented with the same blank screen indicating our empty scene, but the key here is that we have not generated any exceptions from any of our style loading. So it would appear that all of our assets are getting loaded in correctly, all of our fields are getting initialized correctly, and we now have a lot of visual information ready for use here inside of the style class. So with that, that is going to wrap up this video.